In this video, we will solve the questions asked in UGC Net Economics paper of June 2024. The question is, if the cost and demand functions of a firm are respectively given as cost function is equal to C, which is equal to 1064 plus 5x plus x square upon 25, x denotes the output, and demand function is, that is P is equal to 157 minus 3x, P denotes the price here. Then the output at which profit would be maximum is, options are being given. We need to find out the profit maximizing level of output. Okay, so let us see what is the profit maximization condition, or let us write the cost function that is being given as C is equal to 1064 plus 5x plus x square upon 25. This is our cost function, and demand function is being given as P is equal to 157 minus 3x. Okay, now profit, and let me write it here. Profit would be maximum where the marginal revenue of the firm is equal to the marginal cost of the firm. Okay, so that means we need to find out the marginal revenue and marginal cost. So to find out the marginal revenue, first we will find out the total revenue. As we know, the total revenue is simply equal to price times output, that is being denoted by x here. Okay, now what is P? P is being given us as 157 minus 3x. To this we multiply x here. Okay, so this is our total revenue function. Now let us rewrite it as, so multiply this x to each of these terms, it becomes 157x minus 3x square. Okay, now we know that the marginal revenue is simply the change in the total revenue due to the change in the output. Okay, the derivative of the total revenue function with respect to output gives us the marginal revenue. That means we need to differentiate this total revenue function with respect to x here. Okay, so the derivative of x will be 1, so we are left with 157 by power function rule, because the derivative of, if we have x the raised power n, its derivative is equal to n becomes coefficient, then we have x and exponent is subtracted by 1, that means n minus 1, so it becomes here, in this case we have only x here. Okay, so its power is 1, so it becomes 1 becomes coefficient, then we have x and exponent is subtracted by 1, so it becomes 1 times x raised power 1 minus 1 is 0. We know anything raised power 0 is equal to 1, so we have 1 into 1, which comes out to be 1. Okay, so to clear this, why the derivative of x is 1, so I have shown it here by power function rule. So we are left only with the 157 minus, by the same logic, the derivative of x square will be, so x square, its derivative will be 2 becomes coefficient, then we have x and exponent is subtracted by 1, so it becomes 2 raised power x, 2 times x raised power 1, which is equal to 2x. Okay, so derivative of x square is 2x, so 2 into 3 is 6x. This is the marginal revenue of the firm. Now we also need to find out, if I draw a small graph here to make sense here, so we have the output on the horizontal axis and price, marginal revenue and marginal cost on the vertical axis. So we have the inverse demand function, its intercept is 157 and it is downward sloping, because the relationship between price and output is here negative, that is being shown by this negative sign. So we have, this is our average revenue function or inverse demand function. Now that here you can see the marginal revenue function has the same intercept of 157. Okay, so here we have 157, it's what we call, it is intercept, price intercept is same 157, but it is slope is twice that of the inverse demand function. The slope of the inverse demand function is 3x, but the slope of the marginal revenue function is 6x. That means we have 3x here, 6x. That means the marginal revenue function is twice the slope as of the average revenue function. Let's draw the marginal revenue function here. This is our marginal revenue function. Now we need to find out the marginal cost first. Okay, so what is the marginal cost? We know that marginal cost is simply the change in the total cost due to the change in the output. That is the derivative of the cost function with respect to x. The derivative of a constant is always equal to 0, so we have 0. The derivative of x in the second term is 1, so we are left with 5, plus the derivative of x square is 2x by power function rule, so we have 2x, and we have also 25 here. Now what we need to do, so this is our marginal cost function. Okay, it is upward sloping. Let's draw it like this. So we have marginal cost function here. Now as we know that profit is maximized where marginal revenue is equal to marginal cost. What is marginal revenue? That is equal to 1, or let me write it here, 157 minus 6x, and we equate it with the marginal cost function that we got as 5 plus, which is equal to 5 plus 2x upon 25. Now we need to solve for x here. So let's transpose this term here. It gets subtracted. So we have 157 minus 5x. And let's transpose this term to RHS. It becomes plus. Because it is minus here, transposing to RHS, it becomes plus. Okay, it is minus, it becomes plus. So we have 2x upon 25 plus 6x. Okay, I hope I am making myself pretty clear here. So okay, wait a minute, we have only 5x here. There is no, sorry, we have only 5 when we transpose it here. 157 minus 5 is 152. Okay, then we have, let's do the cross multiplication. So we have here 2x plus 6x into 25. 6 5s are 30, 6 2s are 12. It becomes 13, 14, 15. So we have 150x. To this we divide by 25. Okay, so solving further, what will we get? Let us see. So we have 2x plus 150x. It becomes 152x upon 25, which will be equal to 152. Okay, or x will be equal to 152. Now if I transfer 152 upon 25 to RHS, it gets multiplied but reciprocated. So we have 25 upon 152. Okay, those 152 gets cancelled, so x will be equal to 25. That means profit maximizing level of output in this case will be equal to 25. So where the point where marginal cost and marginal revenue functions intersect, it is a point where the level of output will be equal to 25. That is the profit maximizing level of output. Next question is, in a two-sector economy, autonomous consumption expenditure, which is denoted by C0, which is equal to 50 million, autonomous investment, which is denoted by I0, which is equal to 100 million, and B is equal to 0.5. We have to determine the equilibrium level of consumption, which is C, where B is equal to marginal propensity to consume. Okay, so let us write the equation. We know that our total income should be equal to, since we have the two-sector economy, that will be equal to the consumption expenditure plus investment expenditure. What we are being given here? We are being told that autonomous consumption expenditure is equal to 50 million, autonomous investment is equal to 100 million, and B is equal to 0.5, which is marginal propensity to consume, and we are being told to find out the equilibrium level of the consumption in this economy. Okay, so our total income should be equal to total expenditure at equilibrium. So Y will be equal to, we know that our consumption is equal to, what is the consumption function? So we know that consumption is equal to the consumption expenditure plus B times Y. Okay, that is consumption is a positive function of level of GDP or income here. So this consumption, this C0 tells us that if income is equal to 0, our C0 will be a number, positive number obviously. That means we should consume, or we must consume, when our income is equal to 0. If our income is equal to 0, so we should consume something that is being denoted by the autonomous consumption. B is the marginal propensity to consume. This is our consumption function. Okay, so let's first find out the equilibrium level of income, then we can find out the equilibrium level of consumption. Okay, so our Y will be equal to, so we have C0 plus B times Y plus investment is being given us here, autonomous, which is equal to I0. Okay, Now let's give the variables their values. So C naught is equal to 50 in this economy, plus B is equal to 0.5, which is the marginal propensity to consume, and investment is being given us as autonomous, which is equal to 100 here. Let's transpose this 0.5y to RHS. So y minus 0.5 y is equal to 150. If I add 50, add 100. Subtracting 0.5y from y, we will get 0.5 sorry, y is equal to 150. 0.5 can be written as 1 upon 2, y is equal to 150. That gives us y will be equal to, transposing this here, so we get 150 into 2, that means equilibrium level of income is equal to 300 million in this economy. But we are supposed to find out the equilibrium level of consumption. Now we plug the value of y is equal to 300 in this equation, so C will be equal to, equilibrium level of consumption will be equal to C naught, which is being given us somewhere as $50 million, plus marginal propensity to consume is 0.5, the value of B, and equilibrium level of income is 300, which we calculated here. So equilibrium level of consumption will be equal to 50 plus 0.5 of 300 is 150. So we will get okay, so C will be equal to 200. So the equilibrium level of consumption in this economy will be equal to 200. Next question is, in Solow model, if the production function is y is equal to k raised power 1 upon 2 times L raised power 1 upon 2, and S, which is savings per worker, is equal to 0.3 and depreciation is equal to 0.1, then find out steady state level of output per worker, that is y star. Options are being given, we need to find out the correct option here. Okay, so what we are being given? We are being given the production function, that is y is equal to k raised power, that is the capital K here, k raised power 1 upon 2 times L raised power 1 upon 2. This is our production function. Savings are being given us as 0.3 and depreciation rate is 0.1. We need to find out the output per worker at steady state level. Okay, so to solve this question, so what we do first, we write the given equation in intensive form, that is in output per worker form. Okay, so rather the per worker form. So let's divide both sides by L. Okay, and let us denote y upon L. So we have y upon L, let's denote it by small y. So let's write it, that is output per worker will be equal to, so if I solve this equation here, what will we get? And let me write it here. We have k raised power 1 upon 2 times L raised power 1 upon 2 divided by L. Okay, transposing this L here, so we will get k raised power 1 upon 2, then we have L times L raised power minus 1 upon 2. Okay, solving further, we will get k raised power 1 upon 2 divided by, so bases are same, we can add up the exponents, we get L raised power 1 upon 2, that is 1 minus 1 upon 2. So let us write it in this form, that is k upon L raised power 1 upon 2. So let us denote k upon L by small k, that is capital labor ratio. So can I write this function as small k raised power 1 upon 2. This is our production function in intensive form. Okay, so solving further, solving this further, and let me do it in proper manner. So this is our production function in per worker form. Now we need to find out the steady state level of output. Let's draw a small graph here. Let us say we have the capital per worker on the horizontal axis, output per worker on the vertical axis. Okay, what happens at steady state level? At steady state level, what happens? That is the change in the capital stock is equal to 0. And what is the change in the capital stock? That is equal to savings times output per worker should be equal, rather minus depreciation times capital per worker. Okay, this is our fundamental equation of the Solow model. And if I draw it here like this, so let us say this is our output per worker form function. Then we have the savings function, that is, or let's draw the del k, that is differentiation line. Then we have the savings function, that is SFY or SY. Okay, what happens at steady state? All our investment is actually used to cover up the depreciation. That means the change in capital stock is equal to 0, which implies S times Y minus del K will be equal to 0. So what is S? Savings rate is being given us as 0.1. What is Y? Y is equal to K raised power 1 upon 2. Should be equal to, if I transpose, if I rewrite it like this, SY is equal to del K. Okay. So del is being given us as 0.1 and we have K. Okay. Sorry, we have S is equal to 0.3 here. So dividing both sides by, or let's do one thing. So we can write 3 upon 10. So we have 3 upon 10 K raised power 1 upon 2 is equal to 1 upon 10 times K. So 10 and 10 gets cancelled on the both sides. So solving for K, so transposing this K here, which implies 3 is equal to K divided by K raised power 1 upon 2. Solving it further, so we will get K times K raised power minus 1 upon 2 will be equal to 3. Okay, transposing this to numerator, it gets multiplied. So we will get K, so 1 minus 1 upon 2 is equal to K raised power 1 upon 2 is equal to 3, which gives us capital per worker is equal to, transposing this, it becomes 3 square, okay, which is equal to 9. So our capital per worker is equal to 9, but we are supposed to find out the output per worker. Simply plug K is equal to 9 in this equation. That gives us Y will be equal to 9 raised power 1 upon 2, which is equal to 3 square raised power 1 upon 2. So 2 gets cancelled. So output per worker will be equal to 3 in this question. Next question is, if GDP, which is measured in $1 billion, is equal to $5,465 billion and the sum of the consumption, investment and government purchases is equal to $5,496 billion, while the exports are equal to $673 in $1 billion, we have to find out the import level. Okay, so we know our national income identity in case of open economy, which is equal to, that means our total GDP, that is Y, should be equal to the consumption expenditure plus investment expenditure plus government purchases plus exporters minus importers. This is our open economy national income identity. Okay, now this Y is here our GDP. So what is the value of GDP? That is equal to 5,465, and we are being told that sum of the consumption, investment and government expenditure, this is consumption, investment and government purchases, the sum of these three terms is equal to 5,496, while the exporters are equal to $673 billion. That means the value of X is equal to 673. We need to find out the value of importers, which is denoted by M here. Okay, so we have to solve this kind of equation. Now let's do some calculation here. So let's first write 5,465 is equal to, so let's add these two terms. So Shatra gay 9, 9 7 gay Shara, Aka carry Shatsur gay Data gay Ka. So it becomes 6169 minus M. Solving for M, transposing M here, it becomes positive and we get 6169 minus 5,465. That is, we have 5, so let us do here 6169 minus 5,465. Now I pass the 4 0 7, so 5 minus, so we will get the value of imports will be equal to $704 billion. Okay, so next question is, two factors of production, say A and B, have the same price, the least cost combination of A and B producing a given level of output will be achieved at a point where the slope of the isocount has a slope of, options are 2, 0, -1 or -2. Okay. Now what we are being told, we have the two factors of production. We have input A and input B. We are also being told that the prices are same. That is, price of input A is equal to price of input B. Okay. We are being told to find out a point, the level of output will be achieved at a point where the slope of the isocount, we need to find out the slope of the isocount. What will be the slope of the isocount here? Okay. Now we know that in case of, we want to hear what exactly we want to do. We want to minimize cost, which is equal to price of input A times units of input A employed plus price of input B times units of input B employed. Okay, subject to the production isocount. We are not being given the production function. Let us say we have a production function of f of A comma B is equal to some constant, let us say A. Okay, we want to minimize cost subject to the given production constant. Now we note that first order condition for optimization requires that the marginal rate of substitution between good A and B should be equal to the input price ratio, that is price of A upon price of B. Graphically, what exactly is meant by this? If I draw the small graph here, so let us say input A is on the horizontal axis, input B is on the vertical axis. We have this isocost line. Okay, C is equal to PA times A plus PB times B. So if I draw it, it will have a negative slope equal to -1. Why? Here we know that. So what exactly does this marginal rate of substitution between A and B mean? It is actually the slope of the isocount. And let's draw the isocount here. Let us say this is our isocount. So first order condition, or what we call the tangency condition, requires that the marginal rate of substitution between two goods should be equal to the input price ratio. But we know that price of A is equal to price of B. That means this is equal to 1. So this is equal to 1. Price of A is equal to price of B. So can I write MR as between A and B is equal to price of A upon price of A. Okay, which will be equal to 1. But we know that it is actually equal to -1. Why? Because the slope of the isocount will be here -1. It is downward sloping. Okay, since C, if I write cost function as C is equal to price of A and price of B are same, let us say they are equal to 1. So C is equal to A plus B. If I draw the graph of this line, it will be downward sloping with constant slope of -1. Okay, you can check it out by yourself.